Hello, my name is Sam Sitars, and thank you for joining me on my presentation on the Fukushima nuclear accident. This presentation explores what happened during the Fukushima nuclear disaster, how it impacted the environment and people's health. Objectives will look at how the accident unfolded, examine radiation spread, environmental effects, dive into long-term health data, especially thyroid cancer and mental health. Finally, we'll reflect on key lessons learned and what Fukushima looks like today. Alright, a quick rundown of our presentation. We are going to look at a timeline of events, the environmental impacts along with figure 1, the health impacts along with figures 2 through 4 and a table, and then finally we are going to wrap up with Fukushima today and lessons learned. Introducing the Fukushima nuclear accident. So what happened was there was a 9.0 magnitude earthquake off the coast of Japan, which then triggered a powerful tsunami which hit the coast of Japan. Particularly impacted was the Fukushima Daiichi nuclear power plant. On March 11th of 2011 this happened, and it was the second worst nuclear disaster in history with long-term health and environmental impacts. And it's relevant because it highlighted global issues in nuclear safety, disaster preparedness, and energy policy. Alright, we are going to do a quick run through of the timeline of events, starting with the tsunami that strikes the plant, which leads to loss of power and cooling, which also triggers hydrogen explosions, which releases radioactive materials into the air, prompting a mandatory evacuation, which expands 20 kilometers to over 150,000 residents. Next few days, radiation is detected in air, soil, and food. Monitoring begins, food restrictions issued. Finally, around a month later, this accident is rated as a level 7 nuclear disaster. Fukushima caused major environmental damage through radioactive release into air, soil, and the ocean. While smaller than Chernobyl, the impact was still significant. Over 80% of the fallout landed in the Pacific, affecting marine life and fisheries. Farmland near the plant was also contaminated, with some areas still restricted. Unlike Chernobyl, Fukushima released little plutonium, lowering long-term land risks. Still, radiation will require ongoing monitoring for decades. Quick look at figure 1. As I discussed in the last slide, 80% of the fallout landed in the Pacific Ocean, causing that marine mammal risk. 19% landed in other areas of Japan, and then there was about 1% globally, which is very low risk. Moving on to health impacts, we are going to look at radiation exposure, thyroid cancer, mental health, and then evacuation impacts. Radiation exposure after the accident varied by location and role. Most residents received low doses, while the highest exposures were among plant workers and first responders near the site. This map from the U.S. Department of Energy shows projected first-year doses. The highest exposure zones, marked in red, was northwest of the plant, where fallout was carried by the wind. In some areas, doses exceeded 2,000 millirems per year, high enough to trigger relocation under the U.S. safety guidelines. Thanks to the short half-life of iodine-131, radiation levels declined quickly. Still, the long-term health effects and even low-dose exposures continued to be studied and debated. Looking at table number 1 here, this shows how many TEPCO and contract employees were exposed to different levels of radiation after the accident. Most, over 19,000 workers, received less than 10 millisieverts, which is comparable to background exposure over several years. About 8,600 received between 11 and 50, similar to several CT scans. Higher doses were less common. Roughly 1,300 received 50 to 100, and 138 received 101 to 150, nearing emergency levels. The highest group, which was only 35 workers, received over 151 millisieverts, required special medical attention and follow-up due to increased long-term health risks like cancer. After the disaster, a key concern was whether radiation would raise thyroid cancer rates in children, as seen after Chernobyl. Japan responded by screening nearly 300,000 children. As shown in Figure 3, the first round 116 cases were found, sparking fear, but many experts point to screening effect, detecting slow-growing cancers that may never have caused harm. Later rounds showed fewer new cases, 71 than 31. Over 99% of the children had only received low-dose exposure. Still, rounds 4 and 5 saw a slight uptick, 39 and 49 cases, raising continued debate over delayed effects or overdiagnosis. This issue remains emotionally charged and impacts public health evacuation policy, and how we respond to future nuclear events. Japan continues to monitor cases closely and to maintain transparency and trust. Beyond the physical damage, Fukushima had serious and lasting mental health effects. Over 150,000 people were forced to evacuate with little warning, losing homes, jobs, and community ties. Many experienced PTSD, anxiety, and depression, especially those from high radiation areas. Some evacuees also faced stigma and discrimination, which deepened feelings of isolation, especially at risk groups. Figure 3 shows suicide rates from 2010 to 2014. While there was a brief dip in the first year, rates in Fukushima and Iwate rose sharply by 2014, reaching 130% and 145% of pre-disaster levels. This reflects the delayed emotional toll of displacement, uncertainty, and long-term stress. While the evacuation helped reduce radiation exposure, it also led to unintended harm. Research shows that over half of the disaster-related deaths were tied not to radiation but to the evacuation itself. Many patients in hospitals and nursing homes were moved suddenly without proper care. This caused serious health declines and in some cases death, especially among the elderly and chronically ill. The key takeaway is future disaster plans must consider not just moving people but how we move them, especially the most vulnerable. Fukushima led to major changes in how Japan handles nuclear safety and disaster response. Emergency protocols were strengthened, communication around radiation risk became more transparent. Mental health support is now a core part of the recovery planning, recognizing long-term toll of displacement and stigma. Cleanup is still ongoing with some areas reopened, but concern remains. While parts of Fukushima are being revitalized, full recovery is uneven. Many evacuees haven't returned. The disaster's legacy continues to shape policy, science, and public trust. Thank you for joining my presentation today. These are my references that will continue for a second page.